Alright, this is polarizers. And let's see how well this works. Here I had some glare, so I had to turn the lights off. So polarizer only allows through one direction of the electric field vibrating, no matter how I turn this polarizer. By the way, there's some reflection from the lights behind me. No matter how I turn it, it's always the same kind of like faintness. So I'm going to use a second polarizer. So if this one here lets only through vertical lines, and the other one is aligned with it, and again I get a lot of reflection off here, which is actually the Brewster angle. Wow, now I really get a lot. Maybe I have to hold an angle. Anyway, the two are actually aligned, so you can actually still see the print. You might not be able to read it, but at least you can see it. Now I'm going to turn the second polarizer from the vertical position to the horizontal position, and what you see is total darkness. Because now one of them polarizes horizontal and the other one vertically, which means when the light passes through both of them, obviously there's nothing there. Okay, now comes a cool trick. I'm going to use a third polarizer and I put it in at a 45-degree angle. And let's see, I have to put it actually in between. There we go. And let's see if this actually shows up on the camera. And I don't know if it does. Can you actually see something there? In the viewfinder, I fairly make something out. I mean, faintly. Anyway, I have a bunch of videos that I found on YouTube that you can watch, and they're all pretty cool. And then I thought, well, hey, since I do the other little experiment for the thin lens anyway, because you're not getting a Ziploc bag, I might as well do this one here too. Only takes a few minutes. Anyway, this is a calcite crystal, which itself splits up light into two different polarized light rays, and therefore and they're at a slightly different angle, so they have a slightly different index of refraction, and therefore you can see two images. It's called birefringence, respectively double refraction. And if I put a polarizer on top, I hope again we can see that, and turn the polarizer, you should be able to see one or the other print. Let's see, I try that again. Maybe if I don't put it right on top. And through the viewfinder I actually cannot see it, if that's actually true or not. I don't even know what angle it is, if I have to be just like that or if I have to be at a 45-degree angle. So maybe it shows up. But again, there's a number of YouTube videos that show that nicely. Calculator screen. Apparently I did a bunch of thin lens equation computations here. So here's a polarizer. And I think you can see that, right? So here you can actually see what's on the calculator, and here you can't. So the calculator screen, laptops, whatever is LCD displays, they use polarized light. Cell phones, did I already mention that? Okay, if this shows up, that's pretty cool, but again, if it doesn't, I have a bunch of other videos that I found. And let's see, doing this with two hands, holding three things with two hands. So you should be able to see a bunch of colors, because with this polarized light you actually can see the stress points inside this plastic transparent spoon. The one with the corn syrup didn't really work. So the one with the corn syrup may or may not work because the light might be too faint. And I'm running out of seconds, I guess, on here.